Okay, welcome back to math class. Yesterday we talked about multiplying polynomials, and we did a lot of practice problems of varying degrees of complexity. Today what we're going to talk about is 3 different scenarios where we don't have to do as many steps because in these specific scenarios, we know what the results will be when we multiply those polynomials. It'll make more sense as we go, I think. So the first instance of the first special product is when we square a sum. Now a sum is any two numbers added together, right? Like a plus b. Now, and if we square that, it's going to look like a plus b squared. Now this is multiplying polynomials because we know that a plus b squared is the same as saying a plus b times a plus b. Okay, now if I follow my rules for multiplying a polynomial, just like I showed you yesterday, we have to make sure that each term from one, we have to make sure that each term of this parentheses is multiplied by each term in these parentheses. So I'm going to split it up, and I'm going to go a times a plus b plus b times a plus b, because I have to make sure that both of these are multiplied by both of these. Okay, now if I distribute and simplify this, I get a times a, which is a squared, and a times b, which will be ab, plus b times a, which will give us also ab, right? And b times b, which will give us b squared. Now we're not quite finished because I have some like terms in this. We have ab plus ab is going to give us 2ab. So we get a squared plus 2ab plus b squared. That's as simplified as it can go without having any numbers and just having the variables. This equation, well, it's the form for every a plus b squared. So no matter what numbers or variables are in this a plus b, or in for a and b, you can know that if we have a sum squared, this is what it's going to look like at the end. So even if I said 4x plus 3y squared, all I have to do is take each of these terms and put it in this formula. So 4x is in our a spot, so I'm going to take a squared, right? 4x squared plus 2 times a, which is 4x, times b, which is 3y, plus b, which is 3y squared. And now I just simplify it. 4 squared is 16, x squared is x squared, plus, we can do 2 times 4 times 3, which is going to be 24 times x times y, plus 3 squared, which is 9, and y squared, which is y squared. So this saves us the trouble of having to do this step, then this step. It sends us, and this step, it sends us straight to this one, so that all I have to do is plug the numbers in and simplify. The next special product, first we did squaring a sum. Next we're going to do when we square a difference. So a sum was a plus b squared. A difference is going to be a minus b squared. And we're going to work this out together just like we did the other one. We know that a minus b squared is the same as saying a minus b times a minus b. And just like anytime we multiply polynomials, we need to make sure that both of these terms get multiplied by both of these. So I'm going to split it up and do a times a minus b minus b times a minus b. Then I'm going to do a times a is a squared. A times b, we're going to have minus ab minus b times a is going to give us minus ab. Minus b times minus b, two negatives are going to give us a positive. So we're going to have positive plus b squared. All right, we're almost finished. We have some like terms here. So I'm going to do a squared, and I have minus ab minus ab. That's going to give me minus 2 ab plus b squared. Now notice this is very similar to the previous equation. In fact, everything about it is the same, except instead of having a plus 2b, we have a minus 2b. That's the only thing that's changing, and it's because of this is changing. We have a minus sign instead of a plus. So if you can memorize this form, all you have to keep track of is when I'm squaring a difference, I put a subtraction sign here. If I was squaring a sum, then this would be a plus sign. All right, now there's one more special product. So we've done a square of a sum and a square of a difference. Now we're going to do the product of a sum and a difference. So basically we did sum times sum, difference times difference, and now we're doing sum times difference. So we have a plus b times a minus b. And we're going to distribute it just like we're going to multiply them together just like we would anything else. But I'm making sure that both of these terms are multiplied by both of these terms. So I'm still going to split it up. A times a minus b plus b times a minus b now I'm going to distribute both of these. I'm going to write it over here, but don't get confused. A times a is a squared. A times minus b is going to be minus ab. Now I have positive b times a is going to give us a positive ab, and then positive b times minus b is going to give us minus b squared. Now we're almost done. We've got some like terms, but notice this time we have a minus ab and a plus ab. Now if we have minus ab plus ab, those are actually going to equal 0 and cancel each other out. So we're left with a squared minus b squared. So whenever you see a problem that's like a plus b times a minus b, a sum times a difference, it can be just simplified down to a squared minus b squared, and you don't have to do all of these steps, all of these multiplication steps.